So this is going to be a um, new video, a new project. We finished the platformer one in the previous set of videos. This one we're going to do a game that is sort of like Angry Birds. We're going to throw stuff at a structure and try to knock things over. And we'll learn about animations and more about physics, loading different levels, those sorts of things as we go through this project. So initially we're going to start out with using the same graphics that we had from our first game, so just some generic boxes, and eventually we'll bring in some stuff from Glitch the Game, which has tons of free public domain assets if you want to use that in your game. So getting started, I will. Oh wait, we don't want to do that. We want to create a new project, and I will call this thing HappyBears. We're eventually going to bring in some bear graphics, and so yeah, we're gonna we'll just call it HappyBears. And we are going to be a 2D. This thing here is actually a button. May not look like a button, but it actually is. So we'll create a 2D game, and we will create our project. And we're just going to walk through going through all the different steps of making this game and all the different things that we need to do to actually make it work. So here we are. We have our empty project. I am going to drag in our assets from the previous videos. So let me see here, this, and this. And these are just 100 by 100 square PNGs of different colors. So you can go make these if you haven't made them yet. There's nothing fancy about them. They are just squares. And since we set our defaults up as 2D, they come in as 2D sprites. Again, if we set this thing up for 3D defaults, this your texture type would show up as a texture, not as a sprite. So let's just go through kind of building this thing. Go back to our scene view. I hate this generic blue, so I'm going to change that thing just to white. And we'll throw in some clouds and things like that when we get fancier with it down the road. But for now, this is how we're going to start. So let's see. Let's put a platform along the bottom, and we'll just scale it up like this, and it's going to be our platform for everything that's going to stand on it. This will just be sort of like the bottom, the ground level of our game. And we're going to give that thing a box collider, physics 2D, box collider. So everything else we're going to do is going to rest on top of that. And then let's build a structure here. We'll take this thing, black, and we can make some walls with it that we're going to destroy. I'll make it a little bit skinnier. And this is going to be, the structure of our tower. This is going to be something that we're going to knock over. And so because of that, we definitely need a box collider, because we need to have things collide with it. But the other thing that we're also going to need is a rigid body, which is also under physics 2D, rigid body 2D. Because that way when something collides with it, it will actually fall over. So make sure you're using the rigid body 2D, the box collider 2D, because these are 2D objects. Using the 3D physics on this is probably not going to work right. So make sure you're using the 2D options for that sort of stuff. And I am going to, in my assets folder, I will right click and say create a folder, and we'll call this thing prefabs. We'll just start to get a little bit more organized with what we're doing. And I'm going to drag this black thing down into prefabs, which now that means that I can copy and paste this thing all over our project and make it a lot easier for us to do things. So now that I have this prefab, it contains the box collider over here, and the rigid body. So all of that's built into it, and anytime I want to add more to our structure, I don't have to keep adding these things all the time. I can just drag this thing into my scene and then move it over like this, and we can add another one, and that can be sort of like a tower. If we want to rotate that thing, oops. Go. Now it's, kind of like a little bit of a tower. And if we run this game now, let's see what happens. There we go. And so notice that I didn't really line this stuff up all that great. And when it runs, it falls and snaps into place. We can mess around with our box collider. There is, like one little pixel here, which is the border of our box collider on the outside of our graphic. So we could clean that up a little bit if we wanted to, but for right now, that's not going to matter. We don't really need to be too picky on those details. So so when we create an object that we're going to throw, we want it to crash into this thing and have it fall over. And then eventually we'll put little characters, up on top of here that do different things. So that's sort of the next steps that we're going to do. Let's unplay this, and I'm just going to do a quick save. Save it as untitled. Always a good idea to save. So now let's throw in this red thing here, and later on we're going to fix that. This is going to be the object that we're going to throw, and eventually we're going to make this thing into a bear. But since we want this thing to collide with stuff, we're going to add Physics2D box collider just like everything else, and we want it to crash into stuff and have some sort of effect when it hits something. So we will also add a rigid body to this thing. And so if we run, it should fall down to the ground, and it does. Now everything is good. So these towers here, they are going to be able to be crashed into, and they'll fall over. This red thing here now will be able to crash into stuff and make it fall over, and it will also be able to be thrown. We can add a force to it. And so in the previous example, we were adding a force in the y direction to make our guy sort of jump up and fall down. Now what we want to do is we're going to add a force in the xy direction to throw it this way. So we did a couple ways of moving things. We did just adding values to the transition.position. But this time we're going to add force, just like we did with the jumping. And so we want to add force in the x direction and in the y direction. And that's going to give us a nice little arc to this thing. That's going to go like this. And, in Angry Birds, we pull the slingshot back, we do all this aiming and stuff like that. Yeah, we can do all that, but I don't want to get caught up in doing all this triangulation of, which angle you're pulling back this thing and how far you're pulling back, all that sort of stuff. That's not the point of this video. The point of this video is to show you how these different objects are going to interact with each other. So we're not going to get into the specifics of exactly what the Angry Birds mechanics are, but we're going to do a lot of the features just so you can see how these games come together. So I will unplay this thing, and let's create a script. We're going to create a new folder in here. We will call it scripts. And in there we'll create a new C# script, and we will call it player controller. And again, make sure you're not using spaces in these names because the spaces really matter. So we will, I'm going to sort of hide some of these things so that I have the opportunity to drag over my player script. And I'm also, over here on the right, these are just sort of labels for what these objects are. I'm just going to label this thing as player because that's our player that we're going to throw. And you can rename all these things if you want to, but it really isn't overly important. But I am going to label this thing as player, so as we start adding things, we don't start to get confused. But let's edit this thing. And really what we want to do is, I'm just going to add some controls so that when the player, say, pushes on the space bar, we want this thing to jump. And if they push on it multiple times, we want it to go higher. And that's going to be not all that hard. So let's see, what do we want to do? Update. I'm going to say check for key presses, right? So say if input.get key down. And remember, we're going to look for get key down in this instance. If you wanted to look for just get key, that will check every update 60 times a second, whether or not the button is pressed. Doing and get key down is going to check and see, is only going to fire the action the very first time the spacebar is pressed. And so if you want to have this action happen multiple times, you got to push this spacebar multiple times. So it all really depends on the result that you want. So you don't, however you want to do it, you can. In this case, we're going to look for key down. We'll say key code, key code dot space. We will say throw. So yeah, check this out. So throw is something that you would do for when you're checking for exceptions, and it's sort of a reserved function. So we can't name our thing, our new function throw, because it's going to conflict with the standard throw method. So we are going to say throw bear. Right now we don't have a bear, but we will bring in graphics later. So right now we could name it throw red square, but we'll call it throw bear. Okay, so here's our throw bear method, and this is going to be pretty small because all we really need to do is get component rigid body 2D dot add force new vector 2, and this is just like we did in the jumping example before. Exact same line of code, except for in the other one we did only in the y. So right here we're going to do x and y. These are the force in each of these different directions. And in the previous platformer, we only put a value in the y location. But for this case, we want it to go off at an angle, so we are going to put in values for x and y. And this is where, if you wanted to get fancy with it, like we do in Angry Birds, where you have your slingshot and you're kind of pulling back down here, or you're pulling back up here, down at this angle, or this angle, or this angle. All you're really doing is sort of creating different values for x and different values for y. So like if you pull back straight this way, your y value is going to be really small, and your x value will be pretty large because you want it to just launch straight. Whereas if you pull straight down, then you want your y force to be bigger than your x force because you're sort of indicating you want it to go straight up, and if it's this way, maybe they'll be the same. So we're not going to calculate all those angles because that's just math stuff that we can do later. But we're just going to hard code some values. So we'll say public float x force equals 100, and I have no idea if these numbers are right. Public float y force equals 100, and instead of x and y, we will just say x force and y force. That way we'll use whatever values we put in here. So we'll go try and throw this thing, see if it works. If it doesn't, we'll tweak some of these numbers. So let's see what happens. If I run, I'll hit the spacebar once. There it goes. Okay, actually that didn't work out. That worked out pretty good. So normally we would just hit it once. This time we're just going to pound on it as many times as we can, and we can get this whole thing to just fall over. And it looks pretty cool, right? I mean, this is sort of like Angry Birds in a way. All this stuff is falling down. And it'd be neat if we had something on here that we were trying to knock over. But for now, we can just keep playing, and it's sort of, I don't know, it's a little bit entertaining. and yeah, so that's cool. So, so far, without a whole lot of code, we basically wrote one line. We did some checking for button presses and things like that. And then one line of code got us going to throwing our object and knocking the stuff over. So we're kind of getting to a game that sort of looks like Angry Birds. Now, one thing that we're missing is little targets that sit up here that we want to knock over, or maybe put some down here, or that sort of stuff. So that's what we're going to do next. We are going to add in our little guys that we're going to hit, and for that we're going to use little pumpkins. But we're going to do a lot. It's not going to be that straightforward because we're going to use some kind of complex images for that. So let me drag them in, show you what we got here. Here we go. Here comes my pumpkin. Okay, so this thing is, can I rename this whole thing so you can see it? Here it is. Down here is the full name of it. If you go find Glitch the Game assets, you can download those for free. It's a ton of stuff. They're awesome, and it's really cool that it's free. But then you can expand some of the stuff, and you can find this particular PNG. And I think a lot of the glitch stuff was in Flash, so you might have to, like .flas. You may have to convert them out to PNGs. You can just open them up inside of Flash and export them as PNGs. But this is the one that we're looking for, and you can search through the tons of assets to find something that's named similar to this. This may not be named exactly because some of this was I exported with a script, so I may have filled in some of these blanks with underscores, that sort of stuff. But for the most part, this should get you into the vicinity of the right image. And if I just drag this thing in, so this is a pumpkin sprite. If I just drag it in, it's going to look like this. And that's not exactly what we want, right? We want one pumpkin. But what this is it's a sprite sheet. So these are all individual frames of an animation of this little pumpkin laughing at us. And what you want to have happen is you only want one little square, like right here up in the corner. That's how big you want this pumpkin thing to be. And then inside that little square, you want it to just keep kind of cycling through each of these one at a time fairly quickly. And as it does that, it'll have an animation. So these are, kind of like if you ever take one of those books where you flip through the pages and there's different animations drawn on each page, and it looks like a guy's walking when each page is a still frame. That's what this sort of stuff is. And so when you play an animation, you're just going to cycle through each of the individual frames really quickly, and it's going to look like the thing is animating on the screen. And so that's what we want to have happen. But by default, when we bring in the sprite, it's got a whole bunch. It's just one big image, and somehow we got to tell Unity that this isn't just one image. This is a whole series of images that we want to have be in an animation. And that's something that's really powerful and really cool. So I'm going to delete this thing out of here for now, and let's work on building that animation. So one of the things that we can do, so we have our PNG selected. Oops, and I brought it into scripts. I don't want that. Let me just bring it back into assets. So here's our PNG. And over here, we've got our texture type, which is Sprite 2D and UI. That's right. But sprite mode right here is single. We want to change that to multiple. And what that does is it says there are multiple sprites contained within this one sprite sheet. And now we can go and edit the sprite sheet so it knows how to chop it up. So let's go into our Sprite Editor. Yeah, sure, let's import that. So here is our little series of frames for our animation. And we want to slice this thing up. Let's just do automatic and see what happens. Did it do anything? I don't think it did anything. So sometimes this automatic slicing works really good, where it will know that, okay, there's a box that needs to go around this one and this one and this one. Other times it doesn't work at all. And so it is pretty cool that we have the opportunity to do this thing by hand when it doesn't work. So right now I'm hitting slice a whole bunch of times and there's nothing happening. So we will just say grid, and it's going to ask us, the pixel size of each one of these frames. And so it's defaulting to 64 by 64 for some reason. I'm not sure why it chose those defaults, but that's fine. It doesn't matter. It's got to start somewhere. And we hit slice, and now we see all these little squares that highlight what these individual frames are going to look like if we use 64 pixels by 64 pixels. And this is not what we want, right? It's way too big. If this is 64 pixels, we got like a pumpkin and a quarter each way around it, and we don't want that. So I'm going to start just kind of hacking at this thing. Let's make it 60. And all I am doing right now is changing the X and hitting slice, and I'm trying to figure out the right value of X so that there is a vertical slice mark going through each of these pumpkins between them. That's still not enough, so about 58. Not enough. About 50. Still not enough. 48. So now 48 looks like is that too small? Yeah, 48 might be too small. So let's try 49. There we go. Okay, 49 is perfect. And yeah, so normally if you had an artist doing stuff for you, they would tell you what size your grid is going to be for your sprite sheet. But in this case, we got these awesome graphics for free, so and we don't have direct access to the artist, so we just kind of have to guess it out and figure it out. And you could pull this thing up in Photoshop and figure out what this pixel offset is, or you can just sit here and guess and get it done pretty quickly. So we're doing the guess and check method today. Now we need to figure out the vertical slicing, and let's just go down to 50 and see, because they're kind of pretty close to, where'd it go? Slice. So they're almost square. If I do 50, that looks like it's a little bit too big. Maybe still a little bit too big. About 47. There we go. So now we've got this perfect slicing business going on. At our x values of this little rectangle is 49 pixels, and our y value is 47. And so now if I hit slice, we've got this whole thing here, and I can hit apply. And now when we bring in our sprite, it shouldn't look like a million of these things. It should look like one of these frames. And so here are each of our frames. And so if I just bring this thing in now, we get one pumpkin, which is pretty cool. And we can stick this thing up here, and if we run, yep, there he is. And he's already animating. Look at that. So this is new in this Unity 5. You used to have to go through it in a few more steps to build this animation, and this is actually the first time that I am trying this out. And so I am very impressed. We don't have to go through and build this thing by hand at all. Even doing that was easy. This is amazing how easy it is to do this sort of stuff in Unity. Before this, it was a mess. You had to keep track of arrays and pointers and all this sort of stuff of where you're going, where you're indexing, how fast you're doing, all this sort of stuff. And now we don't have to do that at all. It just does it for us out of the box. And it even builds this animation for us. So if you look at him, he's smiling and laughing at us, and it's iterating through all of these different frames. And so that's pretty cool. And here is in our Animator, if you want to see what's going on, you can bring up an Animator tab. And if you don't have one, you can go to Window and Animator, and it'll bring this thing up. And you can see all these different states. And we'll get into animations much later in the course, like more in depth into it, where we can go and we can change our animations from running to walking to idle to that sort of stuff. And these things here are actually states that we can transition to, and we can add more states and that sort of stuff. But right now, here's all the frames that we're going through, and I wonder if this is going to show us anything. Click on this guy. Yeah, here we go. And so here's our timeline of all the frames that we're iterating through. The samples here, we can change this value to get things to go faster or slower. But yeah, so this is pretty cool that it does all this by itself. So yeah, we don't have to actually build the animation, just did it. But there is a couple things that we want to do. So let's see what happens. If we throw this object here, you know, our pumpkin is still just going to sit there and stare at us, and we don't want that. We want it to fall over and land and that sort of stuff. That's the object of the game, right? So in order to do that, I am going to minimize these things, and we will add, just like we did before, Physics2D, a box collider, and Physics2D rigid body. And now let's see what happens. He falls down. And if I throw, it's also going to fall with our physics. See how it fell over there. So that's pretty neat. And you know, again, we're doing a lot of this physics stuff by just adding components. We're clicking over here, and I'm going to rename this thing. It's really long. We'll just call it pumpkin. And when I hit this thing, it will fall over, and everything is good. So this looks like a good place to save. And let's see, what do we got? So if I zoom in on this thing, and we look at our box collider. So here's the collider that goes around this pumpkin, and this is what's going to determine how it falls and how it rotates and that sort of stuff. It's not perfect, right? The collider is a perfect square, but this thing on the inside is not. So you can create you can use a different type of collider if you wanted to. So you could say you want to add a circle collider. Maybe that's a little bit better because it's a better fit for that particular object. Or maybe you want to do a polygon collider, which allows you to sort of draw different vertices going around it to make it more accurate. So I'm just going to stick with box collider because it's good and efficient and serving its purpose for what we're doing here. But if you wanted something a little bit more accurate, then you can certainly add a different type of box collider. You still keep the same rigid body, but you can add a different type of box collider. All right, so I think another thing I want to do is with this pumpkin, I'm going to create a prefab from it. So all you do is just drag it down into your assets directory. I've created a prefab folder to stick it in, which just keeps us organized. Doesn't really mean anything, but it just keeps our stuff organized. So now when I want to add more pumpkins to it, I can just drag and drop them in there. Okay, so here is our pumpkin. Let's do some more things with this. So as we throw it, let's see, and it falls over, we need to make this thing disappear. Now that it's upside down or it's sort of just falling on its edge, we need to have it disappear from the scene. And then eventually we'll do things like once all the pumpkins disappear, then we will go to the next level and things like that. But somehow we need to detect that this pumpkin has fallen over. So we're going to do that with a script. And I'll just create a C# script and call it pumpkin controller. Again, no space. And that is going to be attached to our pumpkin. Now, one of the cool things is, now that this pumpkin is a prefab, I can hit apply over here. And now every single, oops, let me delete that thing. So I accidentally dragged over player controller. I guess it sorted them alphabetically. So I am going to apply that. Start over again. So I will drag in a pumpkin controller, which is just an empty script. But then I hit apply. And what that would do is, if I had more pumpkins in the scene, right now I only have one, but let's say I had 3, 4, or 5 of them. When I have one of the prefabs selected and drag in a component and then hit apply, that gets applied to all of the prefabs in the scene. So having prefabs is really useful because you'll be able to make a change to one of them and have it go to everything. And that makes development a whole lot faster. Okay, so our pumpkin controller script, what we want to do inside of this thing is we just want to detect that the pumpkin has fallen over, and when it has, we will just delete it from the scene. So what we're going to do here is really what we want to do is just check for rotation, right? As soon as this pumpkin rotates, 90 degrees, then we want it to say that that thing we'll consider it gone. So we will say float rotation equals transform dot rotation. And I am going to choose one. So this rotation has W, X, Y, and Z. We're going to actually be interested in the Z rotation. And so that's where I'm going to pull that out of. Now, remember, this is transform, which means it's looking at the object that this script is attached to, the particular object that this script is attached to. And right now, this script is attached to this pumpkin. And if we had multiple pumpkins, we would have essentially multiple pumpkin controller scripts running at any time. And so what this one is referring to is the particular pumpkin that is instantiated in our scene. And just by playing with this before, we can say something like if rotation is less than 0.7f or rotation is negative. And I'll just type this in here for a second, and then I can show you what it actually means. Greater than 0.7f. Then we will say, let's see, what do we want to call this? Pumpkin destroyed. How about destroy pumpkin? And we'll go in here, and we'll make a new method, void destroy pumpkin. And for now, we'll just do a debug log. Destroy pumpkin. All right, so this is the rotation we're looking at. If it's rotating to the left or rotating to the right, either way, we don't care. If it goes beyond that, we want to destroy this thing. And so let's run it and see what happens. Destroy pumpkin. So he flipped over. Destroy pumpkin is called down here. And look, it's getting called bazillions of times because it is still upside down and the script is still running, and we haven't destroyed it yet. All we did was put a printf in here. So if we write some code in here to destroy the pumpkin, then this thing won't be getting called bazillion times. All right, so instead of this, we can still keep this log in here, but let's say we want to destroy object, game object. All right, so I think this may be the first time that we've used this lowercase game object. So a lot of times we've been using lowercase transform, and that sort of is indicative of just the positioning and rotation and scale of their particular object. This game object refers to the whole entire thing. So if we look at our pumpkin, the transform is all of this stuff over here on the right. All of this stuff, little transform refers to all of this stuff. Little game object refers to all of this stuff, and essentially this thing as a whole. And so when we want to delete out of the scene, we want to delete this entire thing. And so that's why we're saying destroy object, little game object. That means whatever this thing happens to be attached to, which is that script happens to be attached to, which is this pumpkin, delete it. Just yank it out of the scene. And so let's see what happens if we run with that. Oh, he didn't fall over. All right. Well, we didn't. I wasn't good at it. Let's try it again. Come on. There it goes. And so as soon as it rotated 90 degrees, the thing disappeared. And that's because, and actually look, it's not even over here on the left. We deleted the entire thing out of our scene, which is exactly what we wanted to do. And the reason is because in our update loop, we get the rotation of our transform. We check and see if it's outside of our bounds that's acceptable. If it is rotated too much, then we call destroy pumpkin. And destroy pumpkin says destroy object, game object. Since it's a little g, that means destroy the entire game object that the script is attached to. And when we watch it go, we'll see that right now we have a pumpkin in our scene. And as soon as it falls over, that pumpkin's gone. It's not here anymore. So that destroy object really worked. We see our printout one time, and then the whole object is destroyed. All right, so that's pretty cool. One thing that I don't like about this is that it's way too quick. A player would be really confused, right? We see him going like this, and then all of a sudden it's gone. It's like, what the heck happened? I don't know. So sometimes, even though we can do things quickly, like we can destroy this object as soon as the rotation is right, we may not want to do that. We may want to wait, like let's say a half a second, so that we give the player a little bit of time to see with his own eyes. It says, oh, wow, okay, so I just did something really good. I'm excited about it. And then all of a sudden the computer realizes it and it's done. If you do it too quick, player might not realize what has happened. Another thing we can do with delays is you can play a sound to let the player know that something good happened, or you play some animation like an explosion, that sort of stuff. So even though we can do this right away, we're going to try and do a delay just to, at least one reason is to show how to do delays. The other way is because it's just better for a player. So here we have this destroy pumpkin, and I'm going to change this a little bit. So right now, this is very linear. We come into update as our code's executing. We do this. We say destroy pumpkin. We come right down in here and destroy it right away. I don't want to do it that much. I'm going to say, let's do this. We want this thing to go in 1 second. 1 second after that the computer, that we realize in our code that it is time to destroy it. Let's wait a second and then destroy it later on. So we'll do this like this. We'll say start coroutine destroy pumpkin. Oops. And what a coroutine does is it's going to allow our function to sort of run in parallel with everything else that's going on. We're not going to be void anywhere. We'll say I enumerator destroy pumpkin. And what that says is that, okay, we're sort of splitting off here. This is going to be a routine that's going to run at the same time that everything else is running. Before, when it was linear, we went straight from this to destroy pumpkin, and the instructions were executing one right after the next one. What we're saying right now is, as we start this coroutine, we're saying, all right, you can move on, whatever the main thread is doing, go do your updates and other objects and things like that. We're going to do some stuff kind of in the background. And so in here we'll say yield, return, new wait for seconds, and we'll say 1.0f. All right, and so what this means is we're going to say we'll start this coroutine. This thing will get fired off, destroy pumpkin. The very first line says yield return new wait for seconds. And so what's going to happen is a yield return says go do something else. When you're finished with that, return back to the same point in this function and continue on going. And so we're going to go wait for seconds for 1 second. And then once it returns, we're going to return back to this particular line in our code, and then just start going down. So I think if we do this, we should see it go a second later. Let's see. Come on, is it going? Is it gonna fall? It's sliding. There it goes. 1,000. Now it's gone. All right, so let's try that again. Maybe I'll get a better one this time. Nope. Right. I don't want to wait for it to slide. Let's see, is that better? There it goes. 1,000. Now it's gone. All right, so yeah, if you want to put anything on a timer, you can do this sort of stuff. You can put inside of this thing, you can put in an infinite while loop if you want to, so that it would go off every second. However you want to do it, this is how you create something that's going to fire off on its own. Start a coroutine. Now, if you're looking at this, there is a problem with it because we have a 1 second delay here. And this thing is still going on during that 1 second. We're doing 60 frames a second. So the very first time we call this, we come in here and we wait for 1 second. This thing updates 60 times, which means we start 60 coroutines. And that's just not very clean. They all go away because we destroy the object, but that's just not the right way to do it. So I am going to put a little bit of code in here to prevent that from happening, because we really only want to have this thing go off once. We don't need to have 60 of them. Even though only one will actually get to this point and then delete the other 59, it's still not very clean. So I am going to put in here a Boolean. We'll call it destroying equals false. So the first time we come in here, notice that we've rotated too far. We will say destroying equals true. And we want to do a check. We will say if, actually it's probably even better to do the check out here. We'll say if destroying equals false, then we will do all this stuff. All right, so this way it's much cleaner. We're only going to have one of these going off at any given time as opposed to 60 of them. And it's just much cleaner. So let's just run it and see. Does it work? Sometimes code looks good, and then you run it and realize it doesn't work. Let's see. Is this one going to work okay? There we go. So yeah, I mean, functionally, we didn't really see any difference. But if you really analyze the code and what's taking place in here, this is a much more efficient way to do it. And it's a good idea to take into account some of these efficiencies as you're building this stuff, because yeah, maybe for this one pumpkin scenario it doesn't matter, but maybe we're going to have 100 pumpkins, and maybe we want to have a really long explosion animation that takes 5 seconds, and so instead of 60 additional coroutines, we have 300, and then we have 100 pumpkins on the scene at once, and so then it's 300 times 100, which is a fairly large number, and all of this stuff is happening, and we don't need to do that because it's just much cleaner to keep it as slim as possible. So, so anyways, yeah, that's that. That's pretty cool. And let's see, our pumpkin here is a prefab, so we should be able to drag in more pumpkins. And put him over there. And let's see what happens. Nothing. Wait, I think, there he goes. Oh, I'm still alive. There it goes. And see how they blew up in sequence. Because remember, each one of these pumpkins has its own instance of this class going on. And so each one disappeared exactly 1 second after it flipped over. And that's how we want it to go. So let's try it again. So watch him again. That guy goes 1 second. This guy, 1 second. He's gone. And so there we go. That's pretty cool. That's working out awesome. And now that we have all this stuff in place, it's really easy to go and put pumpkins all over our scene. And again, that's another thing that's really powerful about this way of developing is that some guy who's really good at coding can come in here and code this thing up, and then the game designers can come in and just start placing the stuff, and they don't need to know what's going on behind the scenes. All they know is they place a pumpkin where they want it to go, and it's going to behave the way they want it to behave. So yeah, that's pretty cool. Let's see, what else do we want to have happen? Let's do something like, let's create an object that's going to know if the level has been completed yet. So what we want to know is we have 2 pumpkins in here, and we want to know that if both of them fall over, that we can go ahead and move on to the next level. And so that's what we should create next. I don't really have any notes for this. I'm kind of making it up off the top of my head. So if it sounds like I'm struggling sometimes to figure out what to do next, that's why. But anyways, you don't need to know that. I have stacks of notes. I am very organized, and I just can't read my writing. No, I'm kidding. So anyways, let's create something that's going to control what's going on with this thing. And we can create an empty game object. So up until now, everything we've gone in here, we've placed in here in the scene has either been some sort of graphic or a camera. But we can also just put in empty game objects that control certain things that may only have code associated with them. And so I will put in here, I'm going to create an empty game object, and I'm going to just call it thrower. I think is a good name. Thrower? Yeah, sure, why not? So we'll call this thing a thrower. And inside of this, we are going to add a script called, well, it's called thrower. Thrower script. And here we go, thrower and thrower script. And so what I want to have happen in this is this script needs to know how many pumpkins are in the scene. And then it also needs to know when any given one of those sort of disappears. So let's do that. Let's edit the script. And what we're going to have here is we will say public transform targets. These are the targets that we're going to hit. And for now, I'm just going to put something in here. I'll say debug.log targets.length. All right, because really the only thing we really care about in this script is how many targets there are, and then how many have been deleted, and how many are left. And so we can put in here, we'll say another thing where we'll say int targets hit equals 0. And then let's make another method. We'll call it public void target hit, which will get called anytime any given target is hit. And we will say targets hit plus plus. And then how about an update? We will say something like if targets hit is greater than or equal to targets.length. We'll do a debug.log, oops, not assert. All targets have been hit. All right, so I kind of cruised through some code there. And essentially what we have now is we've got the code set up to do a lot of stuff, and we have to go finish some of these other pieces. They're not going to work directly out of the box, but I wanted to put this code in here so you had an idea of where we were going. So we have this array of targets, and what we're using that for is the length. So we want, and then we also have this variable here called targets hit. These are the number of targets that have been hit so far. We have a method here called target hit. So anytime one of our pumpkins is about ready to disappear, we need to call this method that'll increment this counter. And then inside of our update loop, we are looking to see how many targets have been hit. If that's greater than or equal to the number of targets that we have, then for now we're just going to print out this message and say, okay, all the targets have been hit. So hopefully that makes sense. I will save that. And when I come back in here with our thrower object, now we have this array of targets. And again, these things are only used for determining how many pumpkins there are. And so an easy way to do that is if we expand this right here, we're going to see that the size is 0. And what we want to do is we just want to be able to drag in these 2 pumpkins into this area here, so that way it'll know that there's 2 of them. But the problem is, so if I take one, I just try to drag this thing over there, that'll, we can put one in there. But we want to drag them both. And so in order to lock this thing here, there's a really neat option inside of Unity. This little lock here, if you click on it, I'm up in the upper right. Now this inspector is stuck on my thrower script. So I can go click on everything over here on the left, and thrower script is still stuck here. If I unlock it, now as I click through here, things are changing. So I want to go back to my thrower, I want to lock it down, and then I want to select my 2 pumpkins and drag it over to targets. And I'm just dragging it right on top of the word targets. And there we go. And so now our size is 2, which matches this thing, and that's correct. Now I will unlock this. And if we run, we see a 2 printed out down here. And what that is representing is this debug log right here, targets.length. So we know that there are 2 pumpkins on the scene. And it's easy. It's kind of better to do it this way. We could just have a number that somebody typed in, but it's a lot easier for somebody who's building a level to not have to sit here and count and say, well, there was 100 of these, or 2 of these, or 3 of those. Just drag in the objects and let the code do the counting. It's a much better way to do it. It's just easier for people to do and deal with. So let's see what happens now if we run. All right, 1 deletes, 2 deletes, and what happened? So we were hoping to see this thing come out because we've hit both targets and we should see this thing come out. But the reason we didn't see anything is because this targets hit variable is getting incremented inside of this method. And we never called this method, right? So there's no reason for this to ever get incremented. And what we want to do right now is be able to increment this thing. And we need to do that from our pumpkin controller, right? Because this is the only thing here that knows about destroying the pumpkin. So somehow in here we need to say something like thrower script dot, let's see what we want to say, target hit. Like that, right? Now this isn't going to work because this thrower script, we don't really have one here. We want to find the particular thrower script that is attached to this thrower object. And that's the method that we want to call. Because in theory, we could have a bunch of different thrower scripts running at any given time. And so having the code like this is not going to run right. So what we were going to do inside of here, we can do something like this, game object dot find. And we want to find this game object, which is called thrower, dot get component. And inside of angle brackets, what's the type of component? Thrower script dot target hit. Oh man, that is long. But that's what we want to do. This is a correct way of doing things. There's other ways to do it, like we could create a variable up here that is of type thrower script and then assign it through the GUI, or we can just find it in code. And so this makes a couple of assumptions. It assumes that there will be an object in your scene called thrower, which in this case there isn't, so I can't spell. thrower. It's kind of a weird word. But now there is a thrower. Is that right? Looks very strange to me. Throw. I guess I'm kind of going crazy, but I think that's how you spell throw. Throw. But let's see here. So anyways, yeah, so that's how we can find those things. There's other ways we can do it. We can assign it. Let's see. I just looked on my phone to see if I spelled this right because it looks so strange, but it is completely correct. So anyways, so yeah, so we find our thrower object, which is this thing over here, and then we say get component thrower script, which is this thing, and then we want to call target hit. And so our thrower script here has a public method called target hit, and it's going to increment this thing every time we hit one. So let's save all this stuff and run it and see what happens. Ink. And it only got called once. So let's try it again. If I'm any good at this. There we go. Oh, dang it. Come on. Oh, it's going to take too long. All right, one more time, and then I'll change the... All right. So I'm going to cheat a little bit. I'm just going to go like this. There we go. 1, 2. All targets have been hit. So now that worked. And again, the code that we had was all in this thrower script because we made a public method called targets hit, which means when we do this kind of business here of get component, that we'll be able to access it. If this was private, we wouldn't be able to see it. But since it's public, we can see it. So we dragged in all of our pumpkins, which filled this array. We initialized our targets hit to 0. And then as our pumpkins fell over, we did this line of code here, which was to find our thrower object, get the component, which is of type thrower script, and then call the method target hit, which is this thing, and that incremented our targets hit count by 1. In our update loop of this empty game object, we just keep checking our targets hit with our length of the number of targets that we have. And then eventually, once we've hit them all, then we hit this debug statement that said, all right, we've hit all of our targets. Now, we can do something else. And instead of this debug log, we could do something like move on to the next level, show a high score, whatever we want to do. That would be the place to do it. So usually when I write code, I'll start with this kind of logic and just put like a log statement in there and say, okay, this has happened. Later on, we'll come back in and fill it in with whatever we want to have, whatever was supposed to take place next. So yeah, that's that. Let's see, what else we want to do. Let's see if I'll move this guy over. I guess one thing we can do next is let's throw. Oh, we still have our bear to throw. Yeah, we can put him in. But the other thing is we can throw more than one of these objects. Like right now we have this player that we keep throwing, but what if we want the player to have more than one turn? We want them to be able to throw multiple things. So one way we could do that, let's try this here for a sec. Let's create a prefab of this thing, and let's just add a second one back to the scene. So what's going to happen? Like in the game, in Angry Birds, you throw one, and then you throw the other. So you throw this one, and then you throw the other one. And that's sort of the effect we want to go for right now. So in this case, oh boy. So I've hit my spacebar, and they're both going at the same time. And that's not what we're looking for, right? We want to throw one, and then we want to throw the other one. I mean, it's kind of cool, but that's not the not the effect that we're going through. And the reason that it's getting all goofed up is because we have two player objects, and each player object has a player controller script. And in the player controller script, we have this business here, checking for the spacebar. And that's not good because this piece of code is running at the same time for both of our player objects. And what we want to do is we want to be able to check for this thing in one area, check for the space, and then we want to call throw bear on the particular bear that we want to throw. And again, it's called throw bear, even though we only have boxes, but we'll bring the bear in a second. So I'm going to change this thing to public. And I am going to cut this piece of code out from the update. So this is public throw bear inside of our player controller, and I've deleted the update code out, and I'm going to go put it inside of this thrower script. Okay, and then the other thing that we need to bring along with it are these X force and Y force. All right, now if we run, bad things are going to happen, right? Oh, all kinds of bad stuff. So he's all mad that we've got, where is the first one? Somewhere there's a problem about X-Force doesn't exist. And it's probably because it's blowing up. Oh, actually, we don't want to move those over. Let's not do that. Mistakes happen. We want these guys to stay there. So yeah, leave these forces there. Sorry about that. That should stay here because this is where we're adding the force. It's actually in the player controller. So those should have been there. My bad. But let's go back to this thrower script. Now let's see what happens. Still mad. Throw bear does not exist. So inside of our update loop, we are checking to see if the key, if the space is down, and then we want to call this throw bear method, and it doesn't exist, which is right because we have throw bear inside of our player controller. We don't have one inside of here, but what we'll do here is we'll make a new method, void throw bear, and there we go. And so now it's not going to complain at us anymore. It'll actually run, but nothing happens when we hit the spacebar. Reason is because we are calling the throw bear method, which is this thing here, and it's empty. What we want to be able to do is sort of control which one of these player controllers we're calling and call throw bear on that particular item. And so if we look at our thrower script, we've got this array of targets that we're using for a count. Let's have an array of bears. So if we say something like public, we'll call them game objects because we want to access some scripts, not just the location of them. We want to access the scripts that are attached to them. Public game object, we'll call it bears. And let's see what happens. Click on my thrower. Now we've got this array of bears. Again, the bears are going to be these red squares. These red squares are going to turn into bears as soon as we bring in the right graphics. So it's kind of strange phrasing right now, but just try to follow my bizarre train of thought. So we have these bears, and I'm going to drag them in one at a time. Here's this bear, player one, and this bear over here. So now we have two of them. And now we can access any of these bears as we want to. So I'm just going to put this code in so it makes a little bit of sense. Bears of 0 because bears are an array. Dot get component. What do we want to call that one? Player controller. Player controller. Dot throw bear. Okay, so if this works, what we're going to do is for the first bear that I dragged into that array, we are going to call throw bear on it. Let's see, does that work? There we go. So yeah, so that took care of that. It's not exactly the behavior that we want to have happen because right now this guy comes up and then I can never throw the second bear. But that's okay because right now we've got it hard-coded for bear 0. And we want to just iterate through each of our bears. And so one of the parts you need to think about right now is, okay, we know when we start out we want to throw bear 0. That's the first one that we got to go. how do we determine when it's time to switch and throw the second bear? Is it when it makes contact with the one of the buildings that we start throwing the second one? Is it when it goes off screen? All these sorts of things. I'm going to just do it simple and say you have 3 seconds to push the spacebar as many times as you want, and then we'll index into the next bear. And so that's how we're going to code this thing up. All right. So I will say bool throwing equals false. Okay. Now we come down here to update. We'll say if we are not throwing, oops, then we will throw bear. And we will also need to have a variable that represents which bear we are throwing. So we will say int bear index equals 0. And I'm going to change this to bears of bear index. Okay. And actually, I'm going to change this too, because we want to be able to hit the spacebar as many times as we want, just like we have been doing. And so, so we'll leave this alone because we want to be able to keep clicking on it. But let's just say if we're not throwing, we will start throw timer. And throwing will equal true. And so what I'm going to do is I'm going to start a timer that's going to go off in 3 seconds. And at the end of 3 seconds, we will set throwing to false, and we will increment our bear index to the next one. Okay, so start, and hopefully this will make sense. So void start throw timer. And in here we'll have an I enumerator. So we're going to do the same kind of timer stuff we did before in our pumpkin controller, like with this sort of thing. I'm just going to copy it. Why not? Work good. This is throw timer. We're going to wait for 3 seconds. And then when it's done, we don't want to do this sort of stuff. But we want to say bear index plus plus, and we will say throwing equals false. Right. And we will say if bear index is greater than or equal to bears.length. Right? We don't want to go off in space. So if we've hit the end of it, we will just say debug.log throw all bears have been thrown. Whoops. All bears have been thrown. Man, this thrown word, this looks kind of strange. Anyways, we'll just print it out for now. It's still going to index, and it's not exactly correct, but like I said, we just want to make sure we have the logic in place. And then inside of here, we say start coroutine throw timer. All right, so if all this works, we should be able to control one of our little objects for 3 seconds, and then we should be able to control the next one. So let's see what happens. Oops. 1, 2, 3. There's the next one. All right, this is a little bit goofy, so let's see. Let's go look at our thrower. I want to switch these 2 elements. Let's do this. Put player, and then player 1. Just because of the sequencing of them, I want the one in front to go first. So we have 3 seconds, 2, 3, Now this guy, can I knock him over? Ah. And yeah. So then we start blowing up down here because index is out of range. But we knew that because we knew as soon as we hit this line here that said all bears have been thrown, that we were going to get an index out of range. And things were going to be bad. So anyways. So let's see. What else do we have in here? Let's see. Maybe we could do different levels. I guess what I want to do is if we hit this thing, we've thrown all of our bears, and the pumpkins haven't fallen over correctly, then let's just reset the level. So instead of this, let's just say application.load level, application.loaded level. So now we should, oops, application.loaded level. All right, so that's going to say if we've thrown all of our bears, just reload the level. And here comes our second one. And then we reload. All right, so we'll put another piece of code in that says all targets have been hit. So if we hit all of our targets, let's go on to the next level. Loaded level plus 1. That'll get us to the next level. All right. So before we do this, let's bring in our bear. I want to change this thing to a bear, make it look a little bit nicer. And so yeah, let's see. Did I bring that thing in yet? No. All right. So where are our graphics? Emotional bear. How about an emotional bear? Here he is. Emotional bear. Lovely, lovely emotional bear. So we want to change these red squares to this emotional bear. And again, it's the same kind of thing. If I were to drag this thing in, we get this sort of grid of bears, and we don't want that because we just want our bear animation. And so we click on it down here on the PNG that we imported. Texture type, again, is Sprite 2D because that's what we set our defaults to. And our sprite mode, we're going to go to multiple. And let's go to Sprite Editor and see what happens. Sure, let's apply. And in here, we'll slice. And hopefully automatic works. And it does. Yeah, so now we have this perfectly sliced up bear by doing automatic. We'll hit apply. And all sorts of things happen. Okay. And then I can drag this thing out here into our scene. And we have our emotional bear. And let's run him and see what he looks like. There he is, swinging his arms, really emotional. So, yeah, let's turn him into one of our players. And the way I'm going to do this, so our player Prefab has box collider, rigid body, and it has a player controller script on it. So I'm going to just change this thing into a new prefab. We'll just call it bear. And we need to give him a physics 2D, box collider 2D, physics 2D, a rigid body. And we also need to add a player controller script to him, right? Like this. So now our bear and our player are essentially the same thing. So that's going to allow me to delete this player from the scene. Oops, delete this player from the scene. And our bear, I will drag him into a prefab like this. And let's position him over here. And let's save. And I'll drag a second bear into my scene there. Move it back. And now the other problem is our thrower. I deleted our game objects from the scene, and because we were throwing those red squares, but now we want to throw these bears. So which one is this? We want to throw this one first. Whoa. There we go. And then we'll throw this one second. And I think everything should just work, right? Here we have our animations. There he goes. Oh yeah, can't load the next level. All right, let's try this. Let's make sure that our bears work, and then we'll work on adding a second level. There we go. All right, so we've got this stuff working. Now we've got our bears, and we're true to our name of Happy Bears. But what we want to do is move to the next level. So in our code, we've got this thing here. If we've hit all of our targets, we want to go to the next level. And right now we just have one level, so there really isn't anywhere to go. But we're going to fix that. So we have our Untitled, which is our level 1. I can just rename that. Level 1. And how about this? Let's get even fancier. Let's make a folder and call it levels. And we'll drag this thing in there. And now I can duplicate levels just by doing Command D or Control D if you're on Windows. And now I have a level 2. And I'm going to double click on that. Shows up here that I've opened up a level 2. And in order to know that we're there, I will just copy this thing and move it up. So now inside of level 2, we've got this thing. I'll save that. And then in level 1, we've got this. And so this isn't going to work, but this is the idea. When we get all of our pumpkins down, like, let's see, can I get this? Yeah. We want to actually go to the next level. And it didn't work in this case because the problem is we want to go to loaded level +1. And if I go to File, Build Settings, there are no scenes in my build list. And it'll always run the particular scene that you've got loaded, but if you want to go jump to other scenes, you've got to have everybody in your list. So I'm just going to drag these things in here. So this, again, I'm dragging from the assets folder down here, level 1, level 2, and this is going to allow us to switch levels when we want to. So we've got that in there, and then, again, I went to File, Build Settings, and then dragged in all of our things. So now if we hit all of our pumpkins, we should be able to go to the next level. There we go. Now we're on the next level. And everything got reset. We started with that guy. And, oh man. And I didn't get it, so we keep reloading this level. And it's still not exactly correct because now we're on level 2. It's going to try to go to level 3. We don't have a level 3, so we probably should have something in there that checks the number of levels, and then, in addition to this sort of check, we check to see if we're on the last level. And if we are, then we do something fun like we roll the credits and all that sort of stuff. So I think that was really all that I wanted to do. We can get a little bit fancier and start adding more graphics. Let's see. Do I have more graphics? No. Nope, I don't have more graphics. So if I had more graphics, maybe we could add some clouds and things like that move stuff around, but I don't, so we're not going to do that. We could add stuff like scoring. If you keep track of how long it takes one of the pumpkins to fall over, or you give the different pumpkins different values when you throw the first bear versus the second bear, that sort of stuff. You could keep track of some kind of score. We're going to do putting text on the screen in the next one, so we don't need to do it right now, but those are some of the other things you can add to this to make it good. But yeah, I encourage you, if you're following along, to look through those glitch assets, and grab not only this bear and this pumpkin, but get other things to make it look so non-generic. Find some nice looking ground, nice looking structure stuff here, maybe put some clouds in the background, and that sort of stuff. And let's see. I mean, you could also do other things like, right now we've got this scene here. We've got all this space. We can make really long levels of all sorts of stuff happening. And then when you throw the object, you can have a camera follow script that follows the bear that you're throwing. Just like we followed our character we were controlling in the last one, you could have the camera follow this thing as it goes through the levels. And that's how you could do that sort of stuff. So yeah, I think that's all we've got for this HappyBears Angry Birds clone. And yeah.